Hello and welcome back. Thank you for joining us with Maths by the Profelo. Here we're doing some practice problems on finding all least non-negative incongruent solutions for each congruence or each equivalence relation. Okay, so we're going to solve 9x is equivalent to 15 mod 24. We need to find the greatest common divisor of 9 and 24. That greatest common divisor of 9 and 24 is equal to, let's see here, 3, right? Because 9 does not divide 24, 6 does not divide 9, but 3 divides 9 and 3 divides 24. And importantly, 3 also divides 15. So I know I'm going to have 3 solutions, okay? Using my cancellation theorem, I know that I can consider this as solving. Divide by 3, that's going to be 3x, is equivalent. Divide by 3, that's going to be 5. Divide by 3, that's going to be 8. That it's going to be equivalent to 3x is equivalent to 5 mod 8. This gets us into a form that we might be able to solve by inspection. And by inspection, x equals 7 is a solution. How do we know that x equals 7 is a solution? 3 times 7 is 21. And 21 is 5 more than 16, which is a multiple of 8. Okay, and I know that my x naught is going to be equal to 7, and I'm going to have plus this 8 times n, where n is going to be equal to 0, 1, or 2, because I need to have 3 incongruent solutions. So that means that my 3 incongruent solutions will be x equals 7, x equals 7 plus 8, which will be 15, and x is equal to, let's see here, 15 plus 8, which would be 23. Of course, we can always double check our math. We can always double check our math and say 3 times 23, that's 69, minus 56, which is a multiple of 8, gives us 13. And let's see here, what did we make an error on here? Let's just double check our work. Let's just double check our work for what we have. And I know what our problem was. Not by 56 for a multiple of 8. We're looking for 24. So excuse me there. So we have that 3 times 23 minus 24 minus 24. And that gives me my 21. So once again, let's just double check what is the error with my solutions, and I just figured out the error with my solutions. Our original piece is actually with 9, so I need 9 times 23. That's 207. So apologies, sometimes we make some mistakes. So 9 times 23, that's 207. Alright, so I subtract 24, I subtract 24, I subtract 24, subtract 24, subtract 24, subtract 24, a couple more times it looks like. And yes, in fact, I have 15 left over. Alright, so once again, 9 times 23, we're saying that's a possible solution. Right, if I subtract some multiple of 24, well, there I have 15, and that tells me that 9 times 23 plus 15, right, is equal to 222, and if I divide that by 24, let's see here, what do I have? Oh, excuse me, 9 times 23 divided by 24, right, minus 8 times 24. There we go. That works out nicely. Okay, so be careful with these. Be careful with these. All right, in this example, let's check this out. 56 and 21, right? Well, 56 and 21, the greatest common divisor between 56 and 21, I believe, is 7. 7 divides 56, 7 divides 21, that's true. 3 does not divide 56, and 3 is less than 7 anyway, so that's going to work out for us. However, 7 does not divide 12, so therefore we have no solutions. We have no solutions for that particular problem. Okay. If we had had 56x was equivalent to 14 mod 21, then we would have 7 solutions, right? Then we would have 7 solutions because we would still have 56 and 21 has the greatest common divisor of 7. 7 divides 14, so therefore we have 7 solutions. And we would say we have 7 incongruent solutions. And we would be able to divide everything by 7. Would be able to divide everything by 7, and that would give us 8x being equivalent to 2 mod 3. And so we'd be saying I need to think of a number times 8 that's going to leave me with 2 left over on division by 3. Okay, and if that's the case, we can come in here, we can check this out. We can say, well, if x is equal to 1, that's going to be 8. 8 is 2 more than 6, so x equals 1 is a solution. Right? And my other solutions, x naught will be equal to 1, and my other solutions will be plus 3n, where n is equal to 1, 2, 0, 1, all the way to 6 to represent my 7 incongruent solutions. Okay, and so those 7 incongruent solutions would therefore be x equals 1, x equals 4, x equals 7, x equals 10, x equals 13, x equals 16, x equals 19, and that would be it. 1, 2, 3, 4, 5, 6, 7 solutions. All right, so once again, it is important to find that greatest common divisor. That greatest common divisor is 7. If that divisor does not divide b, you have no solutions. If it does divide b, there is this nice cancellation theorem that allows us to find these particular solutions more rapidly. You can, of course, always do this the long way using the Euclidean algorithm, but once again, that would take a little bit more steps to solve. Okay? Thank you for taking time with Maths by El Profelo. Realize that sometimes you may make mistakes, but as you have questions, please do reach out.